Are you struggling with casting const to non-const in C? You're not alone. This is a common hurdle for many programmers, especially when trying to replicate library functions. Today, we're going to tackle this issue head-on. I completely understand how frustrating it can be when you're working on a project and hit a wall. It can feel like you're stuck in quicksand, right? You're not the only one facing this challenge, and it's perfectly normal to seek help. Let's dive into the specific question at hand. One user asked, how can I cast from const void pointer to a non-const void pointer in C, especially when using the memchar function? This is a tricky situation, and it's important to understand the implications of such a cast. So, why is this an issue? The const qualifier is there to protect data from being modified. When you try to cast away constness, you're essentially telling the compiler that you know better. This can lead to undefined behavior if the original data is modified. Let's explore how to handle this correctly. And stick around. At the end of this video, I'll share a best practice that can save you from potential pitfalls when dealing with const in C. To address the user's issue with casting from const to non-const in C, we first need to understand the implications of using const. The user should be aware that casting away constness can lead to undefined behavior if the original data was indeed declared as const. Next, the user can use a specific cast to safely convert the const pointer to a non-const pointer. This can be done using a simple cast in the return statement of the function. However, to comply with the strict warnings from the compiler, the user should ensure that the data being pointed to is not actually const. This can be done by documenting the function's behavior clearly. Finally, if the user still encounters compilation issues with the flags enabled, they might consider using a pragma directive to suppress specific warnings related to const casting, but this should be done cautiously. Fun fact, did you know that the C programming language was developed in the early 1970s? It has stood the test of time and remains a foundational language for many modern programming languages. Now let's look at the answers provided by other users. This user suggests an alternative approach for casting const to non-const in C. They note that some standard library functions, like memhere, require casting a const pointer to return a non-const pointer. If your compiler raises warnings, they recommend casting to uint_ptrt before converting to unsigned char pointer. Another option is to use a union with both pointer types. They also mention that using size t for the cast can suppress compiler warnings, but it's important to ensure the cast does not change the semantics of the conversion. That wraps up that answer. Let's move on to another one. An alternative approach suggested by a user involves managing compiler warnings when casting from const to non-const. They recommend using specific compiler directives to disable the warning for just that section of code. That wraps up that answer. Let's move on to another one. This user suggests a workaround for casting const to non-const in C. They recommend casting to size t first to avoid compiler complaints. However, they advise against this method and suggest dropping the wheverything flag instead, as standard C functions have a long history and may not always comply with modern strictness. Here's the best practice I promised. Always be cautious when casting away constness. If you must do it, ensure that the original data is not modified elsewhere in your code. This will help you avoid unexpected behavior. And there you have it. You now have a better understanding of how to handle const pointers in C. Remember, careful coding leads to fewer headaches down the line. If you found this video helpful, please subscribe for more programming tips and tricks.